Hi, my name is Asya Taha, and I'm a third-year physics student at Bilkent University. Today, I'm going to present our PHYS212 project. Our project was about measuring Planck's constant using LEDs, and we also built a spectrometer to measure the wavelengths of our LEDs to compare them with theoretical values. We also built the spectrometer for diffraction images, so we could see how light diffracts. These were the equipment we used to measure the Planck's constant. We first constructed a circuit using the resistors and the LEDs. We tied them together and gave voltage to the circuit. And then what we did was we increased the voltage until the LED started to glow. And at that instant, we noted the voltage. And then, by using this voltage value, we plugged it into the equation that is on the screen right now. And that was how we measured our Planck's constant experimentally. These are the values we obtained from our measurements for red, yellow, green, and blue LEDs. We also plotted our measurements to obtain a scientifically accurate result. For the spectrometer part of our experiment, these were the equipment we used, and this is the setup. For the setup, we replaced the grating in front of the camera. We placed the paper with a narrow slit in front of the LEDs to pass little light and to get good diffraction imagery. We fixed the grating and LEDs using sticks. We also covered the interior of the box with black paper to prevent light reflection. The purpose of this part was to measure red, blue, and green LEDs wavelengths to see if they were accurate with the data sheet. And also to get the spectrometer and diffraction images of white, yellow, magenta, and cyan light, which are a mixture of red, blue, and green lights. The wavelength was measured using a diffraction grating and a camera sensor. Light passing through the grating produced diffraction spots, and the distance in pixels between the central spot and the diffraction order was measured in the camera image. To convert this pixel spacing into a real diffraction angle, the setup was first calibrated by determining the camera's effective focal length, FPX. RGB's LEDs with known wavelengths were used, their diffraction patterns were measured, and the diffraction equations were inverted to find the scaling between pixel placement and angle. After calibration, the diffraction angle for any LED could be calculated from the measured pixel spacing, and the wavelength was then found using the diffraction relation, which is shown in the screen. And these are the final wavelengths we measured. And this is the spectrometer we obtained from the white light. The spectrometers of yellow, cyan, and magenta were described in detail in our report. This was our project. Thank you for listening.